We're going to have our talk for this evening. I'm really pleased that Pamela Gay has joined PSI. Pamela is one of the founders, or she's one of the pioneers of citizen science on the web. She's one of the co-founder of Zooniverse. She reads science fiction for an hour to people every night. Because like, I'm gonna read this stuff, so, well, I'll just do it on the web. And she has her own webcasts, and that she does every week. And so she really, she's an astronomer, so she's like serious science, serious science, but brings a dimension of this social media to PSI that really just complements what we try to do, and I very much appreciate having her on board, and so I would like to very much welcome her to Tucson to talk about what she does, and I think you will all enjoy hearing what she has to say. So let's greet Pamela.
Okay, so we are live streaming this event. Mark mentioned that I am a techno person. Now, I'm a bit nervous doing this because I can't see any of the comments coming in live over the internet and talk to you simultaneously. So I'm going to just have to trust that everything's going well on the internet. As I press play and quickly press exit because I realize that's not my first slide. Let's try that again. So I'm here to talk to you about how when it comes to doing science, a lot of the stereotypes are just not true. And it takes, well, they say it takes a village to raise a child, and I'm going to say it takes an entire global community to raise our understanding of the universe. And this is something, thank you. So if you're like me and you're into random internet things, you may have encountered this fellow, Dr. Horrible. He is kind of the stereotype of a scientist. He is working in his lab with things that boil and bubble and flicker, and he laughs madly. While I can do the laugh, I'm not actually mad. I just do vocal work. And this isn't the best stereotype of a scientist. The only time I've ever worn a lab jacket was because I was wearing black and working in the machine shop and was trying not to wear what I was processing. Yeah, that wasn't what lab coats were meant for, but that's what I used one for. Now, if this isn't your stereotype of a scientist, this might be. And you all know that when he turns around, he's going to have a handprint on each of his thighs of chalk. This is how people think of science. They imagine these people off in their own world, working in their own heads, who can't necessarily come down and talk to normal human beings in vocabulary most of us understand. No, that isn't what it has to be. And as we look back through history, there's this long tradition of regular everyday people making amazing contributions to our understanding of this universe that we all share. And the word citizen science is kind of new. It has only really been around since the early 2000s. But the concept behind what I'm talking about isn't. The concept is there are people out there who have scientific questions. And by talking to people and asking, what did you see? What did you see? By talking to fishermen and finding out where the whales are when they migrate. By talking to farmers and find out what they notice in terms of sunset color versus incoming weather. All these people have helped contribute to science. And it's impossible to say when the first everyday person first contributed to helping us understand the universe. And this is because the first people doing science were called magi and priests and shaman. But these were all people who were outside observing the sky, observing the rising and setting points of the sun, observing how the planets move periodically in a way that can be traced and is cyclical. And they marked it in their architecture, in their engravings, in these amazing monuments they left all across our planet. And these first peoples didn't even have a scientific method. That only came about 400 years ago. You can thank Galileo for that. Prior to that, a lot of science came from, well, people who looked at things and then came up with philosophical ideas, and people who didn't look at things and came up with philosophical ideas. I mean, think about that. Prior to 400 years ago, it was thought that you could divine the complete understanding of our universe just by sitting and thinking. Today, we call those people theorists, and we encourage them to go outside and look up. And we occasionally make fun of them while giving talks. But citizen science has in its roots other things, like the discovery of Uranus by William Herschel. And all of you have probably heard of William and Carolyn Herschel, his little sister. But did you know he was a band conductor? He was an oboist. I was an oboist. Probably not as good as him, which is why I became an astrophysicist. Now, he, like so many amateur astronomers, became one because someone was like, dude, except in whatever they said in Britain at the time, come look through my eyepiece. And he was like, okay. And he was like, cool, after he looked through it. And then he went and he built his own telescope, like many amateur astronomers still do. But he didn't have a choice. There was no oceanside photo and telescope to go to on the internet. So he hand ground his lenses, and it turned out his lenses were the best in the world. Because if you, like me, were ever an oboe player, you know the only way to be in tune is to pull out a scary razor blade and threaten your reed with it. And that reed misbehaves in ways you will regret more than if you misgrind a lens. So I thank the oboe for the telescopes he built. Now with the work he was doing, he and his little sister Carolyn, this is Carolyn, she is by all historical accounts a very good soprano and a very not friendly human being. And she would chase down her brother and, like any good little sister, be like, what are you doing? What are you doing? What are you doing? And he eventually enlisted her as his night assistant. And together they made countless observations. And as they hopped from known star to known star, they found a myriad of objects in between which they mapped. The thousands of objects they mapped became the basis of the new general catalog, that NGC catalog that so many of us still use today. That was started by a conductor who started as an oboe player and a soprano, working in their backyard on telescopes they built themselves. Now, it eventually became clear that Herschel's telescopes were so good that he became the astronomer royal, and his little sister, she also got in on the gig and was paid 50 whole pounds a month as the first woman paid to do science. So, you know, when your little sister's annoying you and you think you're giving her busy work, you might be starting her on a career of science. And this is kind of where it all started, was from people going outside and looking up. And there's a whole lot of stories of the wealthy individual building the amazing machine, Herschel's telescopes, Lord Rosse's telescopes. But the origins of citizen science, amateur science itself, actually lies in the farmers of New England. Back in the mid-1600s, a man whose name I always have to read is John Campanius Home. It's a fabulous name I'm incapable of remembering. This wonderful individual got the idea that we could win the American Revolutionary War that much better if we just understood the weather patterns of New England. And they knew the best way to do this was to gather information, to gather data. And so he started out by asking all the people around him, can you send in weather reports? And then George Washington, Benjamin Franklin, Thomas Jefferson, all our founding fathers got in on the gig. And soon enough, they started collecting massive amounts of weather data. And that early network of weather observers got codified by Thomas Jefferson, who directed that all of this information go to the Smithsonian in Washington, D.C. And from there, it has continued to be used by the National Weather Service. Any of you who've used like WeatherBug on Windows, which you used to have lying down there by your calendar and it would pop up at you with weather alerts, all the backyard weather monitors that relies on, that program is the same program that was founded with our nation. And we still don't fully understand the weather. But because of all those farmers, all those schools, all those individuals who've monitored rain gauges in their backyard, we've over the years gotten that much closer to understanding things. And today we just combine satellites and ground truth from those humans. And it wasn't just collecting data from our own world. It was looking beyond. At Harvard, there was a director who made a great statement of any photon collected by a telescope that is not used for science is a photon wasted. And this got to the point of how can we start to engage all these amateur astronomers who are building their own telescopes? And in the 1880s and 1890s, there were clubs of individuals observing variable stars. Now, for those of you who've never heard of variable stars, that poem by Keats where he says he wants a love as constant as a star, I feel the need to remind him, stars explode. You may regret that decision. And even the most stable stars like our sun, they twinkle and flicker and have pulsations. And there are stars out there that change by factors of 10 over the course of a single night in how much light they're shining towards us. And individuals can go outside with their eyes and look at a star like Delta Scuti and see how, compared to the stars around it, it varies in brightness. And they started at Harvard College Observatory collecting this data and forming the American Association of Variable Star Astronomers. And then there's Milton Humason. He dropped out of he dropped out of school at 14. He became a mule cart driver, as you do when you're living in the early 1900s in California and you're uneducated and you want a good living. And the mule carts he drove carried the instrumentation up Mount Wilson to build those historic observatories. And he was a smart man, just not an educated man. And those two things are so very different. And he kept asking, what is this stuff? And they kept telling him. And when they were done building the observatory, he got a job as a janitor. And he didn't stop asking, what are you doing? Until George Hale, the director of the observatory, said, Milton, I'm giving you a job as Hubble's night assistant. And it was this mule cart driver who dropped out of school at 14, who became a janitor but never stopped asking questions, who took the observations that told us the universe is expanding apart, who took the observations of supernova remnants that told us most of the jewelry we're wearing comes from the stars that have exploded. He was just a curious man. And so often it is that curious human being in their backyard, asking questions, trying new things. The first astrophotography that was ever mastered was mastered in the 1870s by Andrew Ansley Commons, a custodial worker who just thought to put a camera on his telescope. And yeah, that Orion Nebula picture isn't great, but it was the 1870s. And this guy, Grota Riba. I used his data and that NGC catalog for my doctoral dissertation. I used that variable star data for my senior thesis as an undergrad. This is data that gets used through the years. And what Grota Riba did was he was a radio engineer working in a local radio station. And he realized things like Jupiter give off radio light. And any of you can replicate this if you have a dead DirecTV that you regret buying, although you might not. It doesn't rain that much here. Where I live, you deeply regret your life choices because of tornadoes. Now Grota Riba built this in his backyard, and all I can figure is he had more spousal permission units than I will ever have. And yeah, this is his backyard telescope. This is his backyard radio telescope. And the catalog of radio sources he made that he submitted to the Astronomical Journal, when they put it through peer review, they were like, it looks right, but like he's not an academician, except they said it in different words that probably had more expletives. And so they sent a professor to his house to use his backyard telescope and like make sure what he was doing was legitimate. And this is a catalog we still use. And it was just a curious radio engineer who knew what skills it took to disentangle the interference, to make a clear picture of our sky. And had a very forgiving wife. And then living in Tucson. Half of you probably know David Levy. Working on an English master's degree while discovering the first known comet to hit Jupiter. Not the first one to hit Jupiter, just the first one known to do it. And then there's Bob Evans. He discovered 42 supernovae by eye because he had memorized thousands of galaxies. And he would just go, galaxy, no supernova, galaxy, no supernova. And when we moved into the age, he started in 1981, pre-digital camera. When we hit the age of digital cameras, researchers would bring him to sit in the dome with them and look at the pictures coming up on their screen, because he could spot supernovae faster than the software. He had memorized 1,500 galaxies. And now that we live in the day of everyone and their brother has a digital camera, and you can buy digital cameras from Amazon to put on your telescope that are designed to do astronomy, that are better than what I used in my first days at McDonald Observatory. We have amateur astronomers discovering dark spots on Jupiter where the follow-up instrument is the Hubble Space Telescope. Anthony Wesley found a dark spot on Jupiter while testing his telescope in his driveway. It was brand new. He wanted to see what he could see. He looked at Jupiter and hey, the next picture was taken by Hubble. And this has happened more than once. John had to follow up and catch the bright spot associated with the splash. And then we had a myriad in 2016 of amateur astronomers spotting the dark spot on Neptune, again getting Hubble follow-up observations. And dust storms on Mars are hard to see from orbiting space telescopes because they see only a small swath of the planet. And to see global storms, you need to see the globe, which we can see from here better than those spacecraft can see from there. And it was in 2007, the amateurs. It was 2012, the amateurs. And I don't have a picture for 2018 because it was too depressing because we lost a rover, but they did it again. And then they went, and instead of studying one of our own planets, they found a planet around an alien star. There was a group of amateur astronomers in New Zealand working with the MATRA project out of Harvard, where they were looking for stars that, as a background star is sitting there being looked at, some little tiny faint guy would float in front, and its gravity would bend light towards the Earth. And this would get spotted by MATRA. And then they'd hand the project off to the amateurs in New Zealand on the other side of the world so they could keep observing. And the first planet discovered through this really weird, and it would take me an entire talk by itself to explain this technique, method, was found by amateurs in New Zealand with their personal telescopes. And it's not just telescopes that are required. On the left here, those of you who are my age and older will recognize the picture of Mercury that you saw in your textbooks, or maybe you helped make back when the Mariner missions were making their flybys. The image on the right is the exact same NASA data, reprocessed by a philosophy professor who liked Photoshop and pretty pictures and did this in his spare time. Here he is, after he got hired by New Horizons to process images for them. This really confused his university because New Horizons wanted to give him a contract to process spacecraft data, but he was a philosophy professor. They made it work. It didn't really count towards tenure, but he was fine. Did I mention it takes a global community to understand our universe? And all these people are doing amazing things. And if you do nothing else, I'd encourage you to go out and look up. And when you're done, to go online and look at what there is to be seen. This is a screen capture I took earlier today of NASA's Deep Space Network Now website. It lets you see all the data that is currently raining on our heads, which is terabytes of terrifying data. Now, Voyager. It would return like 536 million bits that it was able to store. This was half a megabyte. Half a megabyte. I tweet more than that. This is the sun. There's a friendly little spacecraft, Solar Dynamic Orbiter. It is recording 320 gigabytes of data every single day. Now, install your operating system, install your software. You might have 320 gigabytes left. Imagine someone comes to you with a new laptop every day filled with data and says, okay, you have until the end of the day, and then I'm giving you a new one. We as astronomers and planetary scientists can't deal with this. There are a few tens of thousands of us scattered around the world. I was talking to some gentlemen from Raytheon earlier this evening. And Raytheon in Massachusetts, where I come from, has more engineers in one facility than there are astronomers in the United States. There's not enough of us to deal with this much data. We need help. A lot, really. We do what we can with software. But you can't write software yet. We're getting so close. But we can't yet use machine learning to identify the things we don't know. And this is where, back in 2011, I started to design a project called CosmoQuest with a bunch of different mission science teams, a bunch of humans. And our goal was to say, okay, there's not enough astronomers. And a lot of the tasks we do, our only limiting factor is computers can't do this work for us, but human beings are the best pattern matching system ever. Like, we'd starve if we couldn't, so it makes sense. You want to be able to find that red apple in the tree instead of eating the tomato leaves. You want to eat the tomato. One of those is poison, one of those is not. We're good at this stuff. And so we decided that we would take a three-pronged approach. We would say, hey, we want to inspire all of you and teach you a few things along the way. And this is what I do with my podcast. I share what I know with other humans who hopefully will come back and talk to me and share what they know. Because all of you know something I don't that I would love to learn. You also probably know a few things I don't want to know. But let's share what we know. And then work together to explore. And together, we can discover our universe. And we're working, so our software is currently locked down. We're in the process of a major upgrade as we work with the OSIRIS-REx spacecraft. So don't go try doing this right now. Give me a week or so. So we have software that will allow you to help map out features on other worlds. Moon, Mars, Vesta, Bennu, where OSIRIS-REx is in orbit. And what we've learned from the work we've already done with the moon is if I take 8 professional planetary scientists and lock them up and force them to all map all the craters they can find in the exact same image, they're not perfect. They're going to get bored. They're going to be like, oh my God, there are too many small craters, and they're going to get lazy and stop marking them. And there's going to be about a 20% variation between the person who marks the least and the person who marks the most, because some of them are just going to mark stuff that actually isn't there because you get tired and your eyes get tired. Now, if I give that exact same part of the moon, so the top is the pros. Each one is a different color. The bottom, I took that image and I broke it up into a whole bunch of small pieces. And I gave each of those small pieces to 15 random humans. Some of them were kids, some of them were people who were passionate about doing it. Some of them were passionate and had no idea what they were doing and really made mistakes, but I loved them anyways. And when we took all of these random individuals' data and we combined all of it, it was as good as the pros. If you want the numbers, they're there. I'm not going to read them to you because I want my dessert. And you want to know the winnings of the raffle. I know you do. So you can do this, and you can rock it out, and hopefully you can help us find a rock. Because this little world, Bennu, oh my God, it has rocks. We were not anticipating this. And we need to find one particular rock, one very special rock that is in an area that doesn't have too many other rocks, because that makes it a hazard. Because we're going to take our spacecraft with a device that I think is best described as a very angry vacuum cleaner. And we're going to go in and we are going to touch the world. And we're going to suck up a rock. And we're going to bring it home to Earth to study. And we need your help. Because this world, while only being a few hundred meters across, there's a whole lot of rocks in an area a few hundred meters across. Imagine a quarry the size of 5 football fields. And now you're just imagining the equator. No, you're not. You're imagining the diameter, which wouldn't be football fields. It's bigger than that. And we have to find an area smaller than this room to pick up a rock. And so we're going to have a short period this summer. You don't need to read this timeline. It's just a timeline. We're going to have a short period of time this summer. We're on CosmoQuest. We're inviting people like you who've practiced on other projects. You don't get to do the cool stuff for free. You have to earn it by mapping the moon, mapping Mars, mapping, well, not Vesta, we finished Vesta, Mars, Mercury, the moon. And once you earn it, you get to help us with this. And we're here for you. We're here for you every single day. Have any of you heard of twitch.tv? There's a few, I hear but there's a few hands going up. It's meant for video game players, but we've kind of like taken it over to educate people. And we do a daily news show. And then we put it out on YouTube. Don't worry, you don't have to go to the scary thing called Twitch. You can just Google CosmoQuest YouTube, Daily Space. We put out a daily news show where we're there to help you understand what OSIRIS-REx is doing, what Hayabusa 2 is doing, what all these missions that are at the heart of the science that Planetary Science Institute does. We're helping you know all the discoveries this amazing institute is making possible. The night that Hayabusa 2, that Deborah, I don't know if it's assistant or associate director. Deputy, that's the word. The night the deputy director was working on this mission, she was there and we were covering it live, sharing it out. And we've been doing this for a long time. This weekend, Saturday, if you're bored, I'm going to be online for 10 hours. That's what I do. We've been podcasting the 365 Days of Astronomy podcast, 365 days of a year for over a decade. We figured we owed it 10 hours of attention. So come celebrate. And join our conversation. We're on Discord. I'll bring that back up. But we're here for you. We want to be that place where you go to learn, to discover, to explore, and to be part of the science of the Planetary Science Institute, to be part of the discoveries we make, to live out that mission statement of helping to explore this solar system. And we'll take you beyond occasionally. We cheat on the mission statement. There's more universe out there.
We take it all.
That works. So please, come join us and be part of the exploration. Together, we can discover this universe. Thank you.
Would anybody care to ask Pamela any questions?
And I'm going to see if there's any questions
Pretend you're at a
online.
colloquium.
This is me checking for online questions.
There we go, yes.
Oh, crud, I'm not going to have a chat history.
Oh, no.
Chat, ask the questions again. I'm so sorry. There's 22 people out there watching online. I'm sorry, chat. Okay, there we go. Paranor says, ask away. Okay, there are people out there. So do any of you. How often do you get a PhD astrophysicist willing to answer? You know, we are 1 in a million on this planet. The planetary scientists are actually fewer than us. They're more than... They're less than 1 in a million.
We're special.
Okay, yes, sir.
Do you actually understand some of the stuff we talk about on the Big Bang Theory?
Yes.
Apart from Sheldon.
Embarrassing true story. The first few years that I was married was coinciding with the first few years of the Big Bang Theory, and I was teaching the evening session of Physics 101 for engineers. And I would come home and find my husband watching. I was teaching the night session because astronomer. I would come home to find my husband watching the Big Bang Theory, and I'd plop down on the sofa with him and occasionally correct what was on the television. And he's like, I watch this so I can understand your friends. And I said, I hate you. And then I asked, which of them am I? And my husband told me I was Raj. I hope I'm better now. Okay, looking to see other questions. Yes.
Are there any missions to Europa?
So there's a mission called Europa Clipper. It is scheduled to launch whenever they manage to get the Space Launch Systems rocket working. So its launch date keeps changing. It will go probably in the late 2020s is my current guess. One of the problems that we run into is everyone's like, why don't you just put it on a different spacecraft? And when we build spacecraft, we build them to, the actual word we use is mate, to specific rockets. And if we build something and the rocket we built it for is no longer there, we have to redesign it. This is why Hubble got stuck on the ground, is it was designed to launch in the space shuttle, and it was designed to launch shortly after the Challenger disaster back in 1986. And so it ended up spending 4 years on the ground, which is exactly where you should never store a space telescope. So with Europa Clipper currently being slated to launch on the Space Launch Systems, there are some discussions about moving it to a different rocket. So I can't tell you when, but yes, they're building it. They're actively building it. It's cool. It's awesome. I hope it flies sooner than later. Yep. Other questions? I keep thinking these centerpieces are hands that are up. They're not. Okay, so folks in chat are commenting that Europa Clipper is still in phase A, and that is true. This means that they're building it, but it can be canceled. It's sad. Other questions that are hopefully happier? Yes.
Get another chance, would you get a different mate?
I've been with my husband since 2006. I don't think we can move out of our house. And so I think the answer is I keep him forever because I don't want to move and I kind of like him. Yes.
My nephew told me I was Sheldon, so don't forget.
So for those of you who didn't hear, she said her mate told her she was Sheldon.
my nephew.
Your nephew. Sorry, I misheard.
Her mate says something else.
Okay. Other?
At what age do you think that some of the citizen science projects can be done? How old?
So there's two very different answers to that, and I'm going to give you both. The first one is it depends on how much hand-eye coordination is required. And for ours, what I've learned is they just don't have the needed hand-eye coordination until they're this age. I'm not quite sure what this age is, but I think it's about 6th grade. I don't have children. We test all of our stuff at the local museum on First Fridays, and so we get a plethora of small people coming by and doing amazing things if they're this big or taller. So I think it's about 6th grade and higher. Now, the caveat on that is when you're doing citizen science, you're saying, I choose to contribute to this project. I choose to donate my data and my time, and I recognize the scientists who are working on this are going to make discoveries, they're going to build their careers, they're going to do amazing things because of my volunteer efforts. And a 6th grader may not understand that. And I want the kid who discovers something awesome to understand that he is part of something and he's part of a team and it's not just his discovery, and I don't want them to get hurt feelings. So I think they also need to be old enough and mature enough to understand that they're contributing, and child psychologists tell me that's 13. Are we taking more questions?
Yeah, go ahead.
Okay.
One more.
Yeah.
Tucson High School has an observatory on its roof.
Awesome.
If you have a few minutes and you would send a note to their high school principal, you might be able to get some of those kids to start working for you.
That would be awesome. Thank you for telling me that.
Thank you very much, Pamela.
Okay.
Thank you.
Okay. Goodbye, stream. Goodbye, audience.
These